Hello, everybody, and welcome to your Monday, August 17th video wrap up or video school day for today. What we're going to talk about today is our start of our scientific method, which we did today in class. I'm going to go through how you're going to find that information, then go over a few of the little details that we had going on today that was happening. First off, let me pull up what we've got going on here. You can access the bell ringer still even when you're at home, so I'll show you how to do that. You obviously won't be able to pick up the paper, but I'll show you what paper that we were doing in class and how far you would need to get to in order to keep up with what we've been doing. You can easily copy over all your answers and all your notes if you're not able to print stuff out at home. You'll be easily able to transition that over into notes just using paper. We'll show you how to do that. So our homework is that we're gonna be starting the lab today and continuing it on tomorrow. I'll show you kind of some of the basics of it, and then you're going to learn some of the scientific method. There's 6 steps to our scientific method. We are going to accomplish the first 4 here with today's activity. First off, if you go to our Schoology website, in order to access today's materials, you'll need to go into the August folder. This is the week of August 17th through the 21st. So click on the yellow folder down there. And we are going to be in Monday because today is Monday. So you can click on Monday. And then we've got 3 different things happening here. Our bell ringer, as usual, is right there listed as our bell ringer for today. Now make sure that you are starting a new attempt when you do the bell ringer. You click on that shiny red button there. When you're done, make sure you hit submit, because otherwise it does not get to me. You can go back to Monday, and then these are the 2 things that we're going to take a look at. The Google Doc that is there, the scientific method notes and Penny Lab example, this is what was handed out in class today. We went through, in most classes, through step 4B with everything. So I'm going to show you how that looks when we go about doing that here in just a little bit. The other thing that is listed there is our slideshow, which has all the information in it possible. And that's what I'm going to run down for you real quickly, is some of the things that we talked about in class. Now, when we're looking at some of these items that we're talking about, we're looking at the first 4 steps. Step 1 is state the question. What is the thing that we want to know? And for our experiment that we're doing in class, it's how many drops of water will fit on a penny. Literally right there, we're stating the question. We need to clearly define what you're testing and make it as descriptive as possible. Now, just saying how many drops of water will fit on the penny, that is great because you're telling what you're dropping and you're also telling what you're dropping it on, the penny. You can get real crazy with it, like my example here, and start adding in every little minute detail as possible. But as far as our activity goes for today, just saying simply how many drops of water will fit on a penny, that is going to be descriptive enough for us. Step 2 is you're going to be collecting information. Information is collected either through observations, which is like sight, hearing, smell, taste, and feeling, or researching things that could affect the experiment. The key thing with this is that it must be relevant. So make sure that everything is done with that relevancy in mind. Example number 1 for this would be like the penny has a rigid edge around the whole penny. It's that little raised bump around it. The penny is raised in the middle and there's writing and pictures on it. That could obviously cause it to hold more or less water depending on what side of the penny you use. And you can even use some of the tools. The pipette is the scientific dropper that we will be using in class. They're little plastic thingies. They have measurements on them. We don't call them eyedroppers anymore because nothing should be coming into contact with your eyes. So we'll either use the term dropper or pipette, which is kind of like the fancier version of using some of those things. But step 2 is collecting information, and it must be relevant. What we mean by this is since we're testing water on penny, we don't want any facts about quarters. We don't want any facts about dimes. We don't want any facts about nickels. It's got to be about the penny. We're testing water. We don't want information about milk or juice or any of that other stuff going on there. We want the liquid that we are using so that we know what can affect the outcome of the experiment. Everything else would be, not relevant to us, what we might consider trash. garbage stuff that we don't really care about for our particular experiment. Maybe it's important for something else, but for right now, not so much. Step 3 is that we form a hypothesis. And what that is a prediction for a set of observations that we can test. You might have heard the term educated guess in the past. I do not like that terminology. We're going to use testable prediction for it. And it's written as an if, then, because statement. So how this would look is that the if kind of reframes your question. If water is dropped on a penny, that's kind of our question right there. That's the if statement. Then blank drops will fit. You're actually going to tell me a number in there. 5 drops, 10 drops, 50 drops, whatever it is. That is your prediction. That's step 3 here. And then because is your reasoning. Usually your reasoning has something to do with what you looked up as far as step 2 goes, because you learned a little bit more information about it. You looked at things that kind of forms your opinion on how things are going to run. So because the penny has a rigid edge around it and the drops of water will be small, that's why I'm saying that how many drops will fit on there. So really it's a combination of the first 3 steps all wrapped together is the hypothesis. Step 1 is the if statement. If water is dropped on a penny, how much water can fit on a penny? That's kind of our question that we were asking. Then is step 3, our actual prediction. Blank drops will fit. And then finally, because is our reasoning. This is what really makes it a prediction. Why do you think that is? The penny has a ridge around it. And the thing with all of these is that we do not use personal pronouns. I, my, we, us. We'll get that stuff out of there. This way we are making it more of a statement and we're not throwing any bias into there that people think that we are wanting it to go a certain way. We're instead kind of clearly stating it as a fact. Step 4 is going to be we got to test the hypothesis. We need a materials list. We list out all the materials that will be used in the experiment. In this case, for our materials, we'll need things like a penny, a pipette, a cup, so that we can put water into the cup, maybe a paper towel to clean up with, and you definitely need to have a flat surface. Because otherwise the penny could even slide off the table. On some of those desks, they lean back. We want to make sure that it's flat, so you'll maybe use some of the counter space lab areas that we have. The final thing that we talked about today is step 4B, the procedure. We're going to write down a detailed step-by-step rundown of all the steps used to complete the experiment, basically your instructions. How are you going to complete the experiment? So an example, gather up all the things, lay the penny flat side on whatever side you want to test. Maybe it's heads. Let's use heads. We place it heads up. Use the pipette. Get water from the cup. Place drops of water on the head side of the penny slowly, counting each drop. Repeat until the bubble breaks, because there will be a little bubble that forms, and the water leaks out of the penny. Record the results in our data table. Repeat steps 1 through 6 again to make sure that, we find an average. We get a good number of trials out there. And we clean up the pennies in between each round. It's kind of an important one I forgot to mention on there, but we do need to clean up afterwards because that water, if it's just sitting there, could actually affect it. So we need to make sure that everything's kind of wiped down as we're using it. And that's where we'll leave it off at today. Because on Tuesday, we're going to go through how to actually do the experiment itself. So I'll see you then on Tuesday. Take care.